Welcome to Chapter 6, Geometry, Section 2, Properties of Parallelograms. Find the value of each variable. Pause the video. Join me again to check your work. Okay, so we know that 29x and 61x are these two angles. They're same side interior angles. Same side interior angles are supplementary. So 29x plus 61x equals 180. 29 plus 61 is 90, isn't it? 90x equals 180, so x is 2. In this case, 8y and 6y plus 8 are alternate interior angles. So they are equal. 8y equals 6y plus 8. So when you subtract 2y equals 8 or y equals 4. Good. And then here we have a triangle. Angle sum theorem tells us that the degrees interior are 180. So when we subtract 90 and 72, z equals 18. Good. So today we're going to prove and apply properties of parallelograms. We'll use properties of parallelograms to solve problems. Any parallelogram with 4 sides is a quadrilateral. However, some quadrilaterals have special properties, and these quadrilaterals are given their own names. So today we're focusing on parallelograms. Hint: opposite sides of a quadrilateral do not share a vertex, and opposite angles in a quadrilateral do not share a side. So a quadrilateral like this with 2 pairs of parallel sides is a parallelogram. So to write the name of a parallelogram, we use this little parallelogram symbol. Very cute. We can say parallelogram ABCD by just writing the little symbol ABCD. Good. This could be named starting at any vertex, but keep in mind, from wherever you start, you must name consecutive vertices. So let's say we start here at C. We could actually go counterclockwise. We could say parallelogram C, B, A, D. C bad. So doesn't matter where you start, but make sure that you use consecutive vertices when naming parallelograms or any polygons. So we have some important properties of parallelograms. These are very cool and useful. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So AB is congruent to CD, BC is congruent to AD. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Angle B is congruent to angle D. Angle A is congruent to angle C. Also, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This is quite cool. So angle A and B together, A plus B, equals 180. We could go the other way. Measure of angle A and measure of angle D, see right here, is 180. So any 2 consecutive angles in a parallelogram equal 180. Their sum is 180. Finally, if a quadrilateral is a parallelogram, then its diagonals bisect each other, which means when both diagonals are drawn, then we can say BZ equals ZD, or we could say AZ equals ZC. So they're each cut into 2 congruent segments. Very cool. So go ahead and read this. Find CF. Pause and give it a try. For each of these, do that and come on back. Okay, we know that CF is congruent to DE, right? And that is from our parallelograms. If we have a parallelogram, then you have opposite sides that are congruent, right? So therefore we can say CF equals DE, definition of congruent segments, and we simply substitute our known value for DE. So CF equals 74 millimeters, right? Number 2, find the measure of EFC. Pause and come on back. EFC, right here, EFC. Well, we know FCD. We know FCD. So we know 2 consecutive angles in this parallelogram. We can use that because the sum of 2 consecutive angles is 180 for any parallelogram, right? So now we substitute the known angle, and we simply solve. And the measure of angle EFC is 138. Good job. Try it again. Find DF. Pause and find DF. Come on back. Okay, so DF is one diagonal, CE is another, so we know that DF, DG, and GF are equal, right? And we actually know DG. So two of those would give us the entire DF. So we can say DF equals 2 DGs. Diagonals bisect each other. So 2 times 31, substitute, is 62. Excellent. Finally, we have a real world basketball problem. And here we have a parallelogram, KLMN. Can you find KN? KN. Okay, it is this side down here. And hopefully you see that KN is congruent to LM, isn't it? In a parallelogram, opposite sides are congruent. Therefore, LM equals KN, definition of congruent segments. And so substitute LM is 28, so we know KN equals 28 inches as well. Okay, this is more fun. We're asked to find YZ, and YZ is a binomial, 8a minus 4. And so this is more fun and more interesting. We know that YZ is congruent to XW because this is a parallelogram, right? This should say opposite sides are congruent, right? And so we know that YZ equals XW, definition of congruent segments. So we simply set 8a minus 4 equal to 6a plus 10 and solve. And when you do, subtract your 6a from both sides, add 4, and divide by 2. We have 7. Oh, don't forget that the question is find YZ, so we're going to plug 7 back into the known expression for YZ. 7 times 8 is 56 minus 4 is 52. Here's another opportunity to find an unknown, in this case, vertex, the measurement of angle Z. Okay, so how can we find that here? We know that angle Z and angle W are supplementary, right? They're consecutive angles, and consecutive angles in a parallelogram are supplementary. So let's substitute their known expressions, combine like terms. We have 27b minus 9 equals 180. Add 9, we have 27 equals 189. And divide by 27. And when you do, we have b equals 7. The question asks, what is the measure of angle Z? So plug it in, plug it in. 9 times 7, 63 plus 2 is 65 degrees. Very fun. Can you find JG? Pause, come on back. JG. Okay, JG we know is on the diagonal EG, and because it's being bisected by FH, JG equals JE, right? So we can say that EJ is congruent to JG. Diagonals bisect each other, so they are equal, definition of congruent segments. So let's substitute. We have 3W equals W plus 8. Good. Subtract a W from both sides. 2W equals 8. Divide, and W equals 4. Good. But we're asked to find JG. Substitute. 4 plus 8 is 12. Excellent. Remember, when you are drawing a figure in the coordinate plane, the name ABCD gives the order of the vertices. This is a trickier little problem. We're asked to find an unknown vertex. The 3 vertices of the parallelogram JKLM are given here. 1, 2, 3. Find the coordinates of M. So the first thing we're just walking through this so that you can apply this in another question at another time. But we know 3, so if you don't have this graphed, go graph it. And here we have it, graphed. So there's some unknown vertex, unknown location, but we know it should be labeled M right over here. So we graph these points, and the cool thing is, remember, opposite sides of a parallelogram are parallel, so they will have the same slope, right? So let's just find the slope of KL, and then see if we can create that same slope from J to the unknown M. So slope is rise over run. It's exactly what they do here. The rise is 4, the run is 4. We could have found that algebraically, but since it's graphed, it's easy to count, right? So we can start from the known vertex J, rise 4, run 4, and boom, we have our M. To confirm that we have the right vertex, we can check out the slope of KJ and compare it to the slope of LM, right? And that would confirm that we have 2 pairs of parallel sides. So that's exactly what they do. LM, the slope, is found to be -2. The slope of KJ is also found to be -2. So we have confirmed that M is at the right location, 7, -4. Good. Let's use the properties of a parallelogram in writing a 2-column proof. So again, pause the video if this seems too fast and think a little bit about what's going on. I have just a limited time to create this. So we're going to start with the given information. ABCD is a parallelogram, right? That's just given. We know we're also ending up with what we're attempting to prove. Triangle AEB, AEB is congruent to CED. Okay, so we can prove this using SSS, SAS, whatever you would like to use. So in this case, begin by saying that AB is congruent to CD, right? And that's because opposite sides in a parallelogram are congruent, right? And so we now have that side. Can we prove that AE is congruent to CE? And yes, we can, because they're diagonals, right? And so they say AE is congruent to CE, also BE is congruent to DE, and all for the same reason, that diagonals bisect each other. Good. And so we actually have 3 known sides, don't we? We have AE is congruent to CE, we have BE is congruent to DE, and we have the final side, AB is congruent to CD. So by side, 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 we know that these 2 triangles are congruent. So go ahead and pause the video and attempt this proof. Come on back and check your work. Okay, we're given that these are parallelograms, right? And so we can say that angle H and angle HJN are supplementary, H and HJN. Angle M and angle MJK are supplementary. Consecutive angles in a parallelogram are supplementary. Therefore, we can say HJN and MJK are congruent. Well, that's vertical, right? That's vertical angles. And so we can say that angle H is congruent to angle M, and that's by congruent supplementaries theorem. Okay, they're both congruent to the same supplementary angle. We've got about a minute left video, so pause, give this lesson quiz a try, come on back. Don't you love these questions that do not require a proof? So PW, this big long diagonal, would be 2 PMs, right? We know PM is 9, so PW is 18. And the measurement of PNW, right, PNW, is congruent to WLP. They're opposite angles, right? And we know that one is 144, so we know PNW is as well. Pause and come back. So we know that TQ equals SR, so set them equal, solve for Y, substitute Y in, and you get 28. Measurement of angle T is 71 degrees. Good. And final question, did you graph it? When you did you use slope to find that unknown vertex? The unknown vertex is, good job.